petrochemical industries were developing these nerve poisons. It started initially in World War One, and then after World War Two, this industry really started to develop. And one of the first ones that came out as insecticide was DDT. It's kind of a notorious material. And so what the growers thought, even though this Vidalia beetle has done a good satisfactory job of suppressing the cottony cushion scale, it didn't eliminate it. I mean, there's still some damage that was being done, but it was much more acceptable. So the idea was, okay, we got this new insecticide, DDT, let's start using it as well, and we will eliminate the pest entirely. Well, that was done, and it had great success initially. It wiped out beetle. Guess what it, or rather, guess what it did to the Vidalia beetle? Totally destroyed it. And oftentimes predators and pesticides are effective against them, primarily because they move around so much and they get more exposure. And so they, all right, that's too bad. We lost the predator, but it worked so well, so they kept using it for a number of years. And it didn't really take all that many years. It was like, if I remember correctly, 5, 6, 7 years, and they started noticing, the DDT is not working quite as well. It wasn't quite the dynamic material that had initially been. And eventually got to the point where it wasn't working anywhere near as it used to do. And so they realized that resistance had happened. And I'll talk about resistance a little bit more later. But this was something that was a good example of, when we attempt to eradicate in nature, quite a remarkable ability to compensate and to adjust. And that's what was going on, because the cottony cushion scale pest was able to make some adjustments in their selection of genetics, kind of offspring they were making, that it wasn't affecting the DDT wasn't affecting them any longer. And so that's a good first real great example of how some of these, this was a DDT is a chlorinated hydrocarbon. It also has a lot of other negative effects as well. And not only does resistance take place with it, but it builds up in the fatty tissues of mammals, such as ourselves. And so, yeah, I think the United States, DDT was officially banned in 1972. I believe that's the year. And so it's still used, though, in the world, and especially where malaria is a concern. But even there, some of those countries now, for example, are becoming resistant to the DDT because they've been using it just too often and not changing the mode of action, using different insecticides. And so this is resistance is still occurring. Okay, so as far as insecticide use, and even though this IPM deals with many subjects, I'm kind of emphasize etymological or entomology aspects of it, and that's how IPM originally kind of got its momentum, was the entomologists, those who study insects, and but it includes diseases and herbicides and weeds and all kinds of different materials. So it's just not with insects, but that's going to be my emphasis, primarily because I know that best. So, all right, so as far as when we use insecticides, and this involves pesticides of all kinds as well, not just insecticides, but treat only when it's necessary. There's got to be a reason for your treatments. And then 100% control is not necessary. I do work with very few of the growers I work with have this kind of idea, but they like to have 100% control of any kind of disease and insect when they sell them, and it's reasonable for that expectation, but it's not practical. If you want to get 100% control, for example, against insect pests, that's not management. That's revenge. And so, yeah, that's what that kind of mentality though still exists, and it's difficult to overcome that. But we can have thresholds, and with landscape in particular, we're talking not necessarily so much economic, but aesthetic. The greenhouses and nurseries, that's kind of an economic loss because they have to sell these plants and they don't want to have a very low pest on them, which is reasonable to expect that. But with landscape, you can have a threshold where maybe 5–10% damage is acceptable. Depends upon. So how does this work? And of course, integrated the name of the acronym, methods or many tactics or many strategies, and that's that handout I gave you. I think in most cases I looked at maybe at least 3 different strategies: cultural, biological, and chemical. So IPM still does use chemicals, but the focus is trying to have more what's known as the biorational or reduced risk type of insecticides that have less side effects to non-targets. We're trying to use, using a military analogy, the laser guided missile and not the carpet bombing, which is what the older, more traditional insecticides, the broad spectrum insecticides often did, was just carpet bombing, killing everything. And it's too bad, beneficials are being killed too. That's right. We don't really need them. Not true. We do. We definitely do. And so I'll talk about these cultural and biological and chemical. All right, but just to let you know, I already mentioned it's IPM kind of was first coined in the 1950s. The first year that IPM was used for landscape IPM was an article written in 1963. That was really early for landscape, and most of it really didn't get any kind of momentum until the 90s. Is when it really started. Almost all landscapers and turf managers and so forth, arborists, they really began to understand the IPM approach and what it meant. Okay. And so, as I mentioned already, that IPM works in many different areas or fields. Today, I'm talking about primarily landscape and to some degree turf, mostly landscape. Today, personally, I work with nursery and greenhouse. And then we have things like grain crop farming. Rutgers has a vegetable IPM program. We have a fruit IPM program, and there's a school IPM program. And so there's many different areas, structural pests as well. Okay. And where is this now? Where? Oh, well, where is it? It's most counties. Not all, but majority of counties in New Jersey work with Rutgers Cooperative Extension. And I know Gloucester did at one point. They've kind of gone independent. Well, of course, the main university is in. It's all associated with Rutgers University, but we're a land grant. Rutgers is a land grant university, and so we have agricultural agents within most of the counties have agents, and many of those counties have since, I think for Rutgers, it was toward the second half of the 1980s where they began to develop what was called the Master Gardener program, and it was some education to the general public, open up classes and to be certified and to have certain levels of education reached. And so, there's a handful of counties that no longer work with Rutgers, but a majority still do. Each county is where all the decisions are basically introduced, but we do have a Master Gardener coordinator with Rutgers that doesn't have to be in New Brunswick. In fact, at the moment, I don't think we even have one because the previous one just recently retired about a year ago. So I don't think that person's been replaced yet. Research for, well, there's, oh, that was turf. there's, there's turf research being done all the time. And that is part of Rutgers Cooperative Extension. There's different research fields throughout the state. There's at least, I think there's, I know, two main ones, and there may be some more minor ones as well. But one is in Monmouth County and one's in New Brunswick County. And they have fruit tree researchers, and they're in different counties. So yeah, they're kind of spread around the state. And some, various counties, they have agents and they have specialties in areas of knowledge that they have. Some are vegetable groups, fruits and turf. And so that's, yeah, there's many. And there's grain crop for traditional agriculture. Yeah. So, yeah. And each, there's, I don't know how many county agents we have now at Rutgers Extension. I think there's at least 30, I believe, the last I remember. And they're retiring and we get new hires. And so it's always changing. Yeah. So, yep. Okay. And so when I started with Rutgers in 1995, my job was to be the coordinate the mentoring program for the landscapers and the arborists and turf managers. And I would work with, I probably mentioned this previously, what I say to different groups, but I would work with the private landscape companies. And usually they would have one individual that would be maybe their prime applicator. And they would work with me and I would go visit, and we would go at least 5 times a year, and we would visit maybe for 3 hours. So that's 15 hours during the entire season. And over the 6 years I did that, I worked with 90 New Jersey landscape companies, privately owned landscape companies. And I just kind of go over and work with them as far as observations and diagnostics and what kind of decisions maybe should be made and what kind of reduced risk materials are available, and learning about biological control and even cultural controls, which we'll talk about in a minute. But the first thing I would do is to have them stop doing the cover sprays or the blanket calendar sprays, which was when I started. I was an arborist myself, and I was in the pest management division of this company. And we were just doing calendar cover treatments. That was what was done back in the around 1981 when I started. I did that work for this company for several years, and I went back to college again. But it was a good experience. But we were just doing cover sprays. We weren't what's called. And when we go to a site, it was a private homeowner site, we would just get out of the truck and spray the whole truck landscape down. We would often not even look at what was there. That was our job. We were applicators, which I learned very soon after the first year, this was not the way to do it. But that was how it was fast and easy. You didn't need a lot of training to this. And the companies, many times landscape companies have pretty high turnover rates. There's an easy bar to get into, a low bar to get into the landscape business. And so they would often work for a year or two and they move on to something else. They were tired of doing what they were doing. But I stuck around for enough years where I really started to learn, and spent most of my time not just spraying, but looking at plants, looking at them closely to look for problems and learning about insects and diseases and beneficial insects. And so it became much more, it became more knowledgeable, is all, and had more of a scientific approach and not just being an applicator, which was what back then. And that's what client expected us to do. Our customers, they expected us to be applicators, and that's what we did. So we're going to come away from this covers treatments and be more selective and treat where it was needed and for a reason. And this is a nice diagram to show where the focus on monitoring. It's in the central black, kind of like the axis of a wheel. You don't have an axis, the wheel falls apart. And so you make to determine if any kind of an intervention is needed. There's a problem, and so it needs to be try to be solved. And we have different strategies, cultural, chemical. It's always easy to go right to the chemical. There's not a lot of thinking involved. I just spray it, move on. And maybe that works. Oftentimes it does, and maybe it doesn't. Depends upon what you're dealing with. Insects, it often works pretty well, okay, but other problems, not so much. And so this is kind of the focus where I will prevent should be the base of the pyramid, where it's the highest amount, would be the cultural. And if you don't know what I mean by cultural, you will in just a minute, because it's something you do understand. And biological and chemical would be the least amount of the focus. So this is what I mean by cultural. It's good horticultural practices. If you're a good gardener, you know these things, or if you know, easy things you all do, and aware of the importance of like fertilization and irrigation and pruning and soil aeration, and mowing, simple as mowing. I know I talked about that last time, where oftentimes it's done incorrectly. And then mulching is another one. It's one of those good things that can go bad. Mulching done is a benefit, but it can a detriment if it's done incorrectly. Mulching, as you're familiar with the mulch volcanoes and so forth. And all right, and it just goes on. I talk about these. You could certainly have an entire class, if not an entire course, on all these good cultural or horticultural practices. Okay, and of course, right plant, right place. Obviously, plant selection, proper plant site, and so forth. And so there's a lot here, and there's a lot more that I didn't have room to put on the slide too. And so another area we focus on for a control tactic or biological controls. Again, when I started in the industry in the beginning of the 1980s, the company I worked with, we never talked about biological controls, beneficial insects or these parasitoids. Sure, we knew praying mantids, we knew lady beetles, but that's about it. Maybe we didn't know a whole lot more than that. So I'll talk about these a little bit more in detail toward the end of this particular session. Pathogens, just to finish up with the pathogens, one of our best, I mentioned the spongy moth. So some of the best pathogen that was ever introduced was a classical control, where again they found in Asia, some of the countries in Asia, they have Asian gypsy moth there, or spongy moth, and yeah, it's never stopped. They found in the soil a beneficial fungus, and so they saw that was suppressing the Asian spongy moth pretty well. So they brought this fungi called Entomophaga back into the northeastern sections of the state. Because when I started in 1981 in New Jersey, that was the peak year for spongy moth defoliation. And it was just tearing up our oak trees. And I remember being an applicator, I would use this big, powerful spray gun, so like a rifle. We had to wear kind of a lot of protective equipment, and we'd spray up, 70 feet up in the air. This big, powerful jet, almost similar to maybe not quite as powerful, but as a fire hose. Really shoot up high into the air, and we'd do this in residential areas, and we were spraying things like orthene and 7, which are nerve poisons. And we did a great job of killing the spongy moth, but I would see that, getting with that high up in the air, there would be drift over the residential neighborhood. I never got any complaints, never did, because the nuisance of this caterpillar and all their fecal droppings, and it was just a mess. And so usually most people would come up and say, "Can you spray my property?" and they're concerned with the nerve poisons blowing across the neighborhood. It's of course, I don't think that would be accepted today, but we're talking 45 years ago. So, all right, so that entomophaga worked very well against the spongy moth, and that's why starting kind of by 1990, this fungus had really proliferated throughout many of the areas it was released. It was released in Massachusetts and New York and Virginia, and it spread very rapidly. And as long as we have cool, wet springs, this fungus works well to suppress the spongy moth. So that's another example of a success story with classical biological control, because it wasn't here. Of course, we got our spongy moth from Europe, and actually Europe got their spongy moth from Asia. So it was just a matter of moving over. But today it works well as long as we have cool, wet springs. That's one thing, or maybe a potential. If you notice the climate the last number of years, there's been more extremes taking place. We see this in the news all the time. And one concern is occasionally we do have dry, warm springs. That makes the fungus entomophaga less virulent, considerably less virulent, and so it doesn't do a good job against the spongy moth. So if we, not that this has really seemed to happen in our part of the country yet, but if we start having warm, dry springs, this fungus kind of becomes missing in action, and the spongy moths could suddenly resurge again. But wouldn't take too many years of dry, warm springs for that to happen. So these kind of things, and that's a lot of examples with other pests and insects and weeds and so forth. Can all, yes, it lives in the soil, and it can actually also be present on trees as well. But it's harmless to mammals, but it does do an excellent job of suppressing caterpillars. So does that mean butterflies? Yeah, yes, it does. That affects butterflies too. So there is some negative effect to it, but not so much. It's much more virulent. It seems to target the spongy moth in particular. So the other caterpillars, the impact is considerably less. So enough where it's not considered to be a major significant factor. All right, so when we do file control, we're primarily not, when I again introduced these concepts to the commercial actors I worked with, we were not doing any kind of importation of stuff, obviously, what wouldn't be legal. And then augmentation we're not doing either. And I think I'm probably this to the sort of like gardeners already, but greenhouses, they're doing a lot of augmentation, which means introducing beneficial insects into the greenhouses. And that's been shown the last 15 years to have great success. And as it'll continue to improve more and more, that's releasing both predators and parasitoids, which are these little wasps, and some of them are flies, that there's different species that do a good job of suppressing the pests. And I'll talk about those later. So what is a good IPM pesticide? Relatively host specific. Again, laser guided cruise missile, not carpet bombing. Has a short residual. And that's probably one of the reasons why, I know we've talked about this, the neonicotinoids, things like Merit, and Flagship. These are ones that maybe some of the commercial groups are familiar with. They're now, after October of this year, will no longer be permitted to be applied in residential landscapes. So those neonicotinoids are relatively long lasting. They can last sometimes a year, or at least many, many months. And so the concern with those are pollinators, the impact it has on pollinators, negative impact. Okay. And so we prefer them to have short residuals, and reduce risk to non-targets, soft on beneficials, and so therefore the target ID again, and have less impact with resistance potential. So that's a lot to ask of an insecticide or any kind of pesticide, but at least that's the goal. And so these are some of our major insecticide groups, the organochlorines, which was with the DDTs and the chloridane. They were the chlorinated hydrocarbons, very long lasting. Chloridane had a half-life in soil of 30 years. Great termite control, boy, I'll tell you. And some of the other ones, like the organophosphates, have now been no longer available to us. Dursban can't be used in residential areas. Also diazinon, maybe some of you understand. That was available to homeowners, but it can no longer be applied in residential sites. And so the list goes on, and they're going to be more undoubtedly taking place. The neonicotinoids are now being hit, and they won't be available in some areas. A lot of the agricultural locations, like traditional farming, grain crop farming, as well as the nurseries and the greenhouses, those commercial areas, they can still use the neonicotinoids. Landscapers and residential landscapers longer after the end of this year. And so homeowners can't buy these materials anymore. So, and the more ones with the arrows, that would be called risk, the botanicals, insect growth regulators. I'm spending too much time on insecticides. I don't want to do that. But formulated microbials, a good example there would be BT. Bacillus thuringiensis is what the state still applied to spongy moth populations in some areas where there has been an uprising level, and there's been a lot of egg masses that they have observed have been laid in restricted regions, and they'll spray those with this BT. It does a good job of it's a stomach poison and kills the spongy moth caterpillars. Well, again, will it kill butterflies? Yeah. So nope, nothing that's perfect. And so oil, of course, many of you have used these quite readily. And I promoted the use of for commercial landscapers, especially oils, less soaps, but oils in the landscape, both dormant oils and then in season or verdant oils. You just change the percentage. 1 to 2% during the summer, or 3 to 4% during the off season. You can go higher percentage and have less chance for phytotoxicity or damage. But oils can do a lot to has low impact on beneficials. Once these materials like soaps and oils, they dry, which they dry usually within hours, that's it. It's no longer has any insecticidal properties to them. But both of those soaps and oils, they need excellent coverage to work. But this is what I promoted a lot. And there were some landscape companies that they made the decision that they were going to make the attempt to only use soaps and oils, or sometimes they would combine them too, and it has kind of a synergistic property. And that was done by a couple county pest management, county government. They tried to really eliminate any kind of toxic materials that might have exposure to the public. So they were just going with soaps and oils. They really limited them to a degree, but there's some things they couldn't obviously control with soaps and oils, but that was their main area of applications that they did. Okay. And so as far as the step-by-step of IPM, kind of said monitor, key focus. But you might say, why is it number 2? Well, to be able to do IPM in this approach, some experience and knowledge for it to be able to work out well. So that's why some of the big landscape companies today, they have some experienced people, obviously, but because of the fact that the big production company, I won't make any names, but they have really rapid turnover. And so they're any one particular year, maybe close to 50% of their employees, it's their first year. And so they don't have the experience and knowledge to practice IPM. They wouldn't know how to monitor. And that takes a little bit of effort, minimum, absolute minimum for 1 year experience to know what to monitor for to be successful. And so you do monitor, you make observations that determine by decision making what was there, and if it needs to, addressed, or any kind of intervention is necessary, then you do that using different strategies, of course, cultural, biological, chemical, maybe all of them at once, and then evaluate to see how it worked. If it didn't work so well, you kind of have to reevaluate and to see what kind of changes you can make. So, right? So this was a survey that was done. It's quite a long time ago, but I think it's still important to. I don't, even though I don't work really with landscapers anymore, I've spoken to some of them who have seen this slide. They say, yeah, it seems reasonably accurate as far as their opinion of what they've observed in the field. But this survey to determine what kind of intervention practice IPM or not. But as far as back then, the results came. We had excellent survey results on. We indicate that this one survey, 70% of them were doing cover blanket treatments. That's the old traditional method. So they weren't doing IPM at all. And the 29% said that they were doing see and spray. Still, they weren't monitoring, but at least doing more selective treatments. They were just making applications when it was necessary. But that doesn't work always that well because you didn't catch it early on. And maybe now things are kind of gotten out of hand, damage has already occurred, and you're just too late. Monitor, catch it early. That's not really the way to go. But the big first step was in the blue. A little more than about 8% said that they did monitor. That was the big first step. So, and they were doing treatments. But then only about a quarter of them said that they were IPM. They were monitoring. They were making selective treatments. They were looking at the beneficial insects to determine what kind of control intervention was needed. Could they wait? Was the ratio between the pest and the predator at a good level that it looked like they were probably going to not require to do any treatments? The damage hasn't really progressed to any high level as far as damage to the plant. And so that just means that we have to come back to see if that ratio is being maintained. And that takes a little bit of extra visits sometimes to work that. It's hard to, and I think I have a slide that I'll talk about that. I'm going to hold that thought. I'll get to it in a minute. In fact, this is it right here. So as far as the IPM continuum, if you're not doing IPM, you're doing chemically low decision, limited information. And, that's something that doesn't take any really requirements. You just have to be able to use the equipment properly and safely. And, that was what was done, decades ago. And it's still being done to some level today, especially relatively inexperienced. Then you have maybe a try of this type of tactics, this type of philosophy on if you're a commercial operation, you do it on some of your clients to see if you kind of make money on doing this. Is it going to work? Is it going to take you too much time? Am I going to be able to monitor efficiently? And so that's an emerging program. And then maybe it seems to work on a few of these that you've attempted. And so then you get to a basic program and maybe you have a handful of them and it continues on for a number of years. You're keeping records and that helps a lot to determine each time you go back to speed your monitoring levels because you know where the problems were based on previous records. You don't ignore other places that weren't listed, but at least you have your key focus areas that kind of speeds things up as you monitor. And then you get to a more of an established. When I worked for the company that I did for almost 5 years, I had gotten to the point where I started on my own doing a monitoring. I remember my supervisors, they were very wary of me doing this. Says, are your customers complaining? I said, it's not common. Occasionally a customer will come out and says, why didn't you spray this? I saw you look at these. Why didn't you spray it? But it would be irresponsible, and this is the reason for it. And most of them accepted that. There was always a tiny number, a handful, like a probably count them on my one hand, where they said, "Oh no, you're hired. I'm paying you to spray." And they didn't think of me as a person who had any knowledge. So they weren't paying for knowledge; they were paying for my labor. That was their mentality. But that was relatively few, quite small number, in fact. So I was able to get away with it, and so I was able to start the monitoring and making decisions based on my observation. And as I started to go to these sites and train some of the newer people that came on board, the management kind of got nervous. Now, what are you doing? Now, this is not what we do. We're applicators. and I tried to explain it, and they had enough respect for me that they says, "All right, as long as there's no complaints, you can continue to do it." I'm not so sure we like you training people to do this, though. And I says, "Well, this is the way it should be done." And so that was I kind of got the IPM idea for myself to start doing it, even though universities had already been promoting it now for a number of years. But the company I worked for, they weren't having us trained by any of the university conferences or anything. We were all self-contained. So this was a big production company I worked for, probably 2 or 3 guesses what it was. That was a good experience because I got to see a lot of stuff. Because I had to have a pretty good pace, and I was able to pick up a lot of problems during those few years. And so it's hard to get to optimal. And I worked again with the mentoring program. I worked with some people who were state managers. They were hired by the homeowners, and often, at least on 2 of them, they provided housing. These are expensive places. This was in Rumson. And they had private gardeners come in, and I remember walking some of these estates, and I says, flowers everywhere, beneficial insects everywhere, a lot of really a complex landscape with many different species of plants. I says, I'd be kind of a really irresponsible and maybe even a crime to start this with an insecticide. Kind of, here you had this dynamic equilibrium that had been created between the beneficials and the pests, and the pests weren't really getting out of hand because there was enough predators and parasitoids there to keep them suppressed. So it would have been kind of a shame if I'd come in there and disrupted all that, which I would have done with broad spectrum type of an insecticide. So it's hard to get to optimal, because you've got a lot of biologically dependent, culturally dependent, high decision making, really intensive information, and the fact that these estate managers were living, they had a home there was provided, they were on site, and they could every day they could go out and look around. And I mentioned before about that pest predator ratio. They were able to determine are the predators keeping up with the pests, or things still, there's no real damage being done yet. So they could avoid disrupting that and didn't have to spray. So, all right, what I thought I would do is kind of go through how I mentioned already about pesticide resistance. And I'm going to focus again on insecticides, but the same thing applies as far as resistance applies to herbicides. It applies to fungicides. And so it's not just insecticides, but I want to give you kind of a real brief, simplistic series of slides of how resistance does occur, even though it is really overly simplistic. It gives you the idea of how it takes place. So just to let you know, and this is outdated again, but showing the number of insect species have shown the capability where they've experienced resistance in a certain area where these pesticides are keep spraying with the same mode of action over time. And it's well over 600 now of insect species have shown the ability to develop resistance to a certain known mode of action. And that's why it's important to, when you apply insecticides or herbicides or fungicides, to rotate your modes of action. So don't use the same one each time, so the insects don't start developing and I'll talk about how this works Yeah, the antibiotics is a great example in our hospitals. The bacteria, some of our antibiotics are no longer really very, very effective against at least some of the bacteria, showing strong resistance to some of our antibiotics. And that's an ongoing problem in our hospitals, the antibiotics. Penicillin was around, I don't know, maybe about 1930, I think it first was developed. And it was Dr. Salk, I believe the name was. And I don't think he was associated with Rutgers. I think he was. Yeah. I believe so, yeah. So penicillin, yeah. I don't know, maybe it's probably a team, but people. But Dr. Salk was the head researcher who developed this. And yeah, penicillin is one that was overused a lot, and it's not really one of the better antibiotics anymore. I guess it's still used, but there's a lot of problems with resistance. And I think the list of different antibiotics and resistance continues to grow with problems. All right, so let's say we have aphids. All right, everyone, aphids. They're kind of as I mentioned earlier in one of the talks I gave, they're kind of junior varsity pests in the landscape. They're kind of given too much attention. They are a legitimate concern in greenhouses and nurseries because you can't ship out your plants that are infested with aphids. But in the nursery, rather in the landscape, we can accept a pretty good level of aphids, even though early on they maybe distort and curl up the foliage, the new growth. But in this case, yeah, aphids, they have parthenogenetic production, give birth to live young. So it's just depends upon the temperature, but within a week they can have a new generation. And they can have multiple generations in the summer. And so their number can build up really, really rapidly. And so let's say you have this aphid population at a certain area of your landscape, for example. And we notice that the ones that are in green are considered to be susceptible to whatever broad spectrum material you're about ready to use, okay? And so you apply it, and the one that has the X or the red, that is just a very small percentage of this wild population, this group that you're about to spray. And that's not really, it's been maybe in the past had some importance, but as the hundreds of thousands of years by, this particular enzyme, or maybe a complex number of enzymes, have not really had that much value, and so it's not replicated readily. It's kind of a latent genetic part of the insect's genetic makeup. But suddenly you start applying this pressure of an insecticide, and suddenly this enzyme becomes valuable for at least a very small percentage, far less than 1% of the population. They are able to break down with their enzyme, break down the active ingredient of the insecticide really rapidly. And so it doesn't kill them. And so they're able to reproduce. And so, all right, well, it's a very small percentage, so maybe that's not all that. We'll get the vast majority of them, and you do. And so you come back, you spray them, broad spectrum insecticide, and you did a great job, maybe 80, 90%, in fact, 90% are considered to be excellent control. 80% or above is considered to be good. Even 70%, it might be satisfactory. You kind of want to get much below that. But say that, oh, I did a great job. I kind of solved that problem. Well, you really didn't, because remember, these aphids reproduce rapidly. New generation, maybe once a week in some cases, depending upon the temperature again. And so you come back again, maybe just a few weeks. Wow, they're back. What happened? All right, that's okay. I got this great insecticide. I'll spray it again. Same mode of action. One change, though, you may have noticed, after that reproduction, and maybe been a number of different reproductions taking place. The ones, the percentage that has this resistant or maybe a complex number of enzymes, it's increased because they were not killed and they were able to reproduce. And so there's a little bit higher level of the total percentage of this population has these enzymes now. And so, all right, well, see what happens. We spray the same material again. Wow, great job. Really. Just now we're solved. We got it taken care of. No, you don't. Okay, you come back again, maybe a few weeks later. Wow, what's going on? And this is really jumping ahead of things much faster than it actually will take place. It takes multiple generations, but we're doing it really very rapidly. So what has happened is that you have pressured this population to change, and the only ones that are really successfully reproducing are the ones that contain this resistant enzyme, this enzyme that's able to break down the active ingredient of the insecticide rapidly. So they are slowly over time becoming the dominant proportion of the population. This select area that you're making the same treatment again and again. And so you apply the same material again, one last chance, you think, and now they're all successfully killed off all the susceptible ones, but you have naturally made a natural selection for those ones that have this resistance capability. So your sprays forced the resistance to occur. You forced the population to make this genetic change in their makeup. Same thing happens with the bacteria in the hospital. If you keep using the same antibiotic again and again, the same thing can happen there too. It's a form of natural selection. Right? So the insecticide resistance or any kind of the speed of potential resistance, the number of generations per year, that's why things like aphids and spider mites have really rapid generation. Spider mite, one that you're probably most familiar with, is called the two-spotted spider mite. I've talked about that before. And so they're the ones that maybe have 15 generations in the summer. And so that would help to speed of resistance if you continue to pressure them with the same mode of action. When I mean mode of action, I explain this. It means how the pesticide works against the target and what's it doing to affect the lethality of the insect or the disease or the weed, for example. Number of offspring per year as an offspring, both spider mites as well as aphids produce tremendous numbers per female over a period of time. Okay. Yes. So does that mean in terms of like soft body yeah, the question was as far as using different materials like neem oil or insecticidal soap. Again, you mentioned kind of specify against soft body insects. I kind of lost my train of thought. Where was I? I was going to answer that question. I had it all ready to go. Is this senior dementia? Is that setting in? I'm starting to find that happening occasionally here and there. Yeah, the label, the insecticide or the herbicide or fungicide label, they have resistance management suggestions. And some of them, it's mandated. You have to follow to be correct under the law. You have to follow their resistance management. And they tell you sometimes how often you can spray this material before you have to go to a different mode of action. And there's these codes, they're called IRAC, which is Insecticide Resistance Action Committee. There's a Fungicide Action Resistance Committee. And these are codes, and they put these different insecticides or fungicides or herbicides based on mode of action. And so they're given a certain code, the same maybe number or letter. That means they all have that under this letter number distinction, they all have the same mode of action. So even though the name change hasn't taken place, there's things like in some insecticides that have different name changes, different brand names, but they may be both of them may be organophosphates. And so they would be under the same code, and that would have the same mode of action. And so you have to change it to a different mode of action. So they do help you determine, when you need to make a change, when the label says you can maybe spray this 3 times a year and that's it, then you have to go to a different mode of action. And so I think that maybe answers your question. But yeah, you have to rotate them. The old rule of thumb before these codes came out, they've been around for 15 years or more, 20, maybe 15 years, maybe 20. Before then, the rule of thumb was a spray a material with the same mode of action no more than 3 times, then you change to a different mode of action. But they've become more specific than that. They would be. You mentioned neem oil. That is different than a soap. That has different modes of action. Yeah, soaps and oils would be under different IRAC codes. And so oils work as kind of indirectly. They work as a suffocant. They disrupt the sphericals of the insects, so they can't breathe properly. Whereas a soap acts as a desiccant, and it emulsifies the cell membranes and causes the cells to kind of burst open, and they desiccate. So 2 different modes of action. And both of those materials, by the way, it's very difficult for an insect of any to develop resistance to those materials. So yeah, there's some materials that resistance is much less likely to happen. Whereas other ones, there's some insecticides, for example, they have it on the label. You can use this material once in a year. That's it. You can't use it again. And it tells you that because they're so concerned with resistance potential. So, I mean, that's, people don't read the labels sometimes very carefully. I mean, if you ever have insomnia, it's a great remedy. And so, but there's some great information. They spend millions of dollars to produce these insecticides and the labels, and they did a lot of research on it. And so it's good information to know if you take the time to read it. So, right? So, how might Barry? We go until 10:30.
Yeah,
we take a break. What time do you have?
10:10.
10. You got 20 minutes. Okay. All right. Let's talk about what we call primary pest resurgence. And this is another problem when we're dealing with these broad spectrum pesticides. And that would include things like carbamates, which are 7. We're all familiar with 7, I think, is an insecticide. And then orthene is organophosphate. These are they, pyrethroids is another example of a broad spectrum material. You can buy pyrethroids as off the shelf of garden centers and so forth. They will have different brand names on them, but they're essentially pyrethroids, and they have pretty long residuals. They can last 2-3 weeks, 3 weeks on woody bark, a couple of weeks on leaf tissue. So they can last a long time, and they're just general bug killers. And so they can develop resistance problems more rapidly. Okay, let's talk about primary pest resurgence and how this happens. All right, it's all off there at the top. Which plant is infested with spider mites? Yeah, what do you think? The left or center or the right? Spider mites. Spider mites, we've talked about. I think I've even showed this slide. I did. So this, as far as the certified gardeners, you've already seen this. So maybe I could have skipped this over. But yeah, I've already gone through this scenario. Yeah. So let me just skip it. but there's the two-spotted spider mite there on the left. Actually, two-spotted spider mite didn't feed on these plants. This was fed upon by spruce spider mites. Remember, spruce spider mites feed on conifers, but they're cool season. And this occurred in the spring and the fall. Two-spotted spider mites is that summer mite, and they're more commonly going to be found not on conifers. It's possible they can be found on conifers, much less likely. They're going to be on broadleaf trees, deciduous trees. But there's the predator there on the right. There's different species of predators, and they have longer legs and move a lot more faster than the pest. Yeah. Yeah. Well, no. I did talk about this, and what happened to the plant on the left, it was the soil had overly saturated. So they drove all the oxygen out in that region. It was a soaker hose the homeowner put, wrapped it around the trunk of the tree. These are columnar arborvitaes, and he just wrapped it real tight around the tree there on the left. And he let it go too long, the homeowner did, and it saturated the soils and it killed the tree or killed a lot of the roots. It's not totally dead, but it killed many of the roots. Yeah. Okay. Yeah. Well, yeah, I mean, she's question was, or comment really, what's going on with these are arborvitae? Yeah, same. Yeah, I mean, they're very shallow rooted. How many people on their properties have had during this past year, at least in Monmouth County where I lived, we had a pretty good drought. And we did lose. In fact, I lost a good sized arborvitae in my front yard. I haven't cut it down yet. It's still there. But okay. Japanese maple rusting. I'm not sure what could be going on there. I don't know. Probably not spider mites. Yeah, probably not spider mites. Possible. Could be maple spider. Yeah. Fungal pathogen there? I'd have to see it. I don't know. It's nothing that I'm used to seeing much. I see a lot of this Japanese maple, you said. Yeah, I see them all. They're very popular in nurseries. And I don't remember seeing symptoms like that. So I'd have to see it. Yeah. Okay. Okay. Yeah. Well, anyway, just kind of since I already talked about this, I guess 2 weeks ago or 3 weeks, 4 weeks ago maybe, with the spider mites. The predators are an important part of it to keep this pest from developing. And so I showed you. I didn't show this graph, or did I? Oh, good, good. It just indicates with pest resurgence, you see the red one, they would be representing the spider mites, for example, and say it's on an arborvitae. And then we got the green, and that's maybe a group of different predators, predaceous mites, or maybe things like spider mite destroyer is a common name for a particular type of lady beetle, and there's various different predators that keeps the two-spotted spider mite, or the spruce spider mite in this case, under control. And you notice that there's a kind of a black line there at the top called the threshold, the density. It's time and density. As long as you put the density below that threshold, which before the pesticide was applied, it was successfully doing. You had developed a dynamic equilibrium had taken place where the pest and the predator ratios were kind of maintaining. They wax and they wane, and they respond. The predators respond to the number of pests and how they wax and wane over time, but they were doing a good job of keeping things below the threshold, so there wasn't a problem. And so if someone's doing a type of a calendar cover treatment, not really looking at the saying, oh, it's time to spray the trees with an insecticide, you can disrupt that. And that's what happened in this particular example. where, in this case, it would have been a miticide, and so the mites drop way down low, but you pretty much eliminate the predators. And there's always a time lag when we're dealing with predators versus pests. The pests typically have an advantage of being able to reproduce more rapidly. And so therefore, for the period of time, the beneficials aren't really doing a whole lot. It's taking them longer to recover from the insecticide or the miticide in this case. And therefore, the pests can get a jump, a head start, and they can start taking off. And it does take a while for the predators to catch up because of that time lag. And so where before you did not need to make this application, now you do. So that's called primary pest resurgence. It's creating a problem where previously none existed. And I assume in my early years, and all the landscapers who did this type of operation, they were routinely having this occur. And it's called a pesticide treadmill. You are being forced to apply your pesticides because you're disrupting what nature had tried to, create an equilibrium. Well, you keep disrupting that, but unnecessarily wasn't needed here at all. And so, and I think the pest outbreak is maybe a little more realistic because there's a little more complexity here, and we'll take a break. In this case, we're dealing with scale, and this is oyster shell scale. I think maybe all of you are you familiar with this? There's only about 6 or 7 common groups or families of scales that we find in our landscape. By far, two of the biggest groups, and there's many species within each of these groups, are the armored scales and the soft scales. I mean, there's felt scales, much fewer species, and there's things. Well, mealybugs are technically a type of a scale, but the soft scales and the armored scales are the dominant by far, and this happens to be a problem with the secondary pest outbreak, especially with armored scales, because of this waxy coating they use to protect themselves. They're a very successful group. In fact, that's why they dominate our scales populations of the types. They're going to be primarily, a good percentage of them are going to be armored scales because of they're so successful, and they're able to survive really well because of this waxy cover that they produce over themselves. And so I think euonymus scales. We talked about euonymus scales a few weeks ago. I know we did. And feed on Pachysandra and of course euonymus. And they are a wax producer cover, and so they're an armored scales. And I have a euonymus plant in my yard. Every year this time of year it's eaten almost clear to the ground by deer. They love that plant, but then each year the roots are vigorous enough, and it's a pretty good sized plant. It comes back, and by the end of the year it's just full size again, and just keeps going back and forth. It just keeps living though, and that also has had scales on it, and the euonymus scales. All right, and the crawlers, and I know I did talk about this, so I'm repeating myself to some level, but it's just a quick review. And all the yellow ones there, the white ones are the males, the females, the lays the eggs. They're mostly going to be on the twigs, and they have a oyster shell appearance to them. But those yellow crawlers are maybe only about 3 times the size of a spider mite, and so they can be viewed without a hand lens, and often they're kind of colorful, yellow, red, purple. Yeah. Yes. Yes. As far as the question was with armored scales and the crawlers, or soft scales as well, or any kind of scales, the crawlers are the most vulnerable stage of the insects, of the scale insects, and they have these little tiny legs that don't work particularly well. And if you knock them off the plant as they're crawling, and they don't all hatch at once, There could be different microclimates within a particular plant that they're infesting. And a more shaded side might take several days longer to hatch, for example, before the crawlers come out. And so there may be several weeks, depends upon the species of scale as well, because sometimes you have 1 or 2 generations where they're going to be crawling. And so if you're going to go with a jet spray of water, if you know what time of year to look for them, you can find these scale crawlers. And then if it's a relatively small plant and within reason, you can take your garden hose and make a jet spray out of it and just spray and knock all the crawlers off. A good percentage will be on the ground and they're not going to have the ability to climb up. Maybe a few will, the majority will not. And so you may have to do this several times though during that particular generation when the crawlers are all hatching and moving around. These crawlers only have like 2 or 3 days to settle down and start feeding and start to produce the wax over themselves. But it takes that wax cover. It's composed of kind of a waxy material, but also their own fecal material. So they're very efficient on all the body materials that they have, and it covers themselves like, might liken it to the engine in your car. You have the hood that protects it over. That's what these covers will do. And so when the crawlers come out, they have to get out from underneath the female cover because they can't all feed in such a tiny area. And the female dies after she lays her eggs, and so then they all leave the mother protection of the mother's scale. They move around, maybe don't move very far, maybe just a few feet. And they find the locations to settle down and then start putting their mouth parts into cells of the plants. And then they start feeding and they can produce a waxy cover over themselves. So yeah, I mean, that's the vulnerable stage of time. And so that was one of the biggest concerns with landscapers, when the fact that they can no longer use one particular type of neonicotinoid called dinotefron or safari. It's one of the outstanding armor scale controls, and they've lost this material now after this year. So they're going to have to there's other alternatives that can use, but maybe in some cases they may resort to trying to time the crawler periods when they apply maybe their oils or soaps, or a homeowner can just go with a jet spray of water. So yeah, that's a long. Vegetable gardens, scaled. Yeah, there's certain types. Vegetables, they're crops out area of expertise. I don't work with vegetables, but I know they have to get certain types of scales. I'd have to review which ones they are though, because I don't work with vegetables. Yeah. Woody ornamentals and turf is what I've done for my career. Yeah, which is a lot. There's so much to learn. So, yeah. All right. And so I want to kind of finish up with this, with why gales can be controlled and so such a valuable, beneficial. And these are the parasitoid wasps. There's an example one here. There's a species, and they often will be host specific on the type of scale that they'll go after. Predators are more generalists. They'll feed on a lot of different types of hosts. These parasitoids, which are the the parasites that kill host. That's what a parasitoid is. Fleas are not going to kill the cat. That's a parasite. But a parasitoid like this parasitoid wasp, which is it's a female that's laying her ovipositor, which egg laying on a side profile view of a scale, and it's putting its egg through the wax, and then as that egg hatches, the wasp larvae will then begin to feed on the body of the scale. And if you remove the waxy cover from an armored scale, what's there, the insect, is like a blob of jelly. I mean, it doesn't have legs. The legs have atrophy. It doesn't have the antennae. Doesn't have eyes. They don't need that because they're spend their entire life underneath this waxy cover. All they have is a mouth part, basically, that inserts into cells of the plants, and they suck up chlorophyll chloroplasts and photosynthates that the cells are producing. So this is really a valuable predator. And what they do is they larvae feed and consume the scale, and then they complete their go through a metamorphosis. They become the adult wasp after they consume the scale, and now they're trapped underneath this waxy cover, and they have to get out. Right? So they cut their way out. The adult wasp cuts its way out. They can leave the scale and vacate it. Same thing with aphids as well. So those are probably the two best examples of parasitoids work. But they can go after bagworms, other caterpillars that are very common. Some of you, I think I may have photographs of this. I'm getting ahead of myself. Let me just finish this up so we can take a break. And so this is the graph, and we'll take a break after I go through this. This is showing you the same, pretty much the same type of graph, the density on the y-axis, time moving from left to right. And you notice in this case, a little more complexity there. You've got the primary pest in red, let's say it's the scale insect. You have the beneficials, which are in this case, I'm focusing on the parasitoids, these wasps. You know, there are different, there's fly parasitoids, and there's wasp parasitoids, and they're quite tiny, you know. The wasps, they don't have any interest in people. They won't sting us or anything like that. If you see one, you kind of looks like a gnat. Maybe it gets in your eyes. Silly gnat, get out of here. Maybe it was a parasitoid. And so it's nothing that you need to be concerned about, but they're very valuable. About more wasps in the landscape, about 1/3 more flies. These are different species. Okay. They're considered to be parasitoids, beneficial. So in this case, the black indicates, I'm sorry. The red one in this case, let's say it's the spider mites that we had previously, or an aphid. Now, the black one are the scales, okay? The ones with this protective armor. So if you go in here with a broad spectrum insecticide, for example, and again, what's happened so far as you move through time, you notice the threshold there at the top, it's well below the threshold, not a problem. Both the aphids or the mites, whatever the other primary pest in red is, they've been maintained. It means they're being, like this dynamic equilibrium against being maintained. They wane as they move through their up and down cycles of their population. But then disrupt everything. We come in here with an unnecessary broad spectrum insecticide or pesticide, and everything is obliterated. So therefore, where previously you had no problems, but because of this time lag and the beneficials aren't able to recover very quickly, it takes a while, they were both over time being able to accelerate rapidly. And where you had none problems, now you got two. So that's called what's known as secondary pest outbreak. And it happens really commonly with scale insects because you are applying it against the scale stage that may not be during the crawler period. And so you're just covering the waxy, covering, and it doesn't have really much of an effect against the scales. And so you're killing off their predators and the parasitoids that were keeping their populations in check. And now you said, well, the scales say, thank you very much. Now I can really take off and become a problem, where before it wasn't so much. So that's the example of a secondary pest outbreak. A little more complicated, but more realistic. And maybe the final statement I'll say is that when my experience back as working as with this arborist company in the pest management division, some of us fellow applicators, we would sometimes discuss things when we were all back at the branch. I say, I remember some of us would say, those clients that have the worst scale, the armored scales, are the ones that we've been working with the longest. Because we've been promoting scales because of these broadcast cover calendar treatments that we've been doing. And usually if it's more than like 5 years or more, we're really promoting scales, and it takes them that long to really start to build up. And so we were doing a disservice to the homeowners. We were we were promoting scale insects, armored scales with our practices that we were doing. So, and this has all been backed up by university studies, as this graph is based off of. This is, there's no numbers on here, right? So that doesn't, they're not an individual experiment. Maybe many individual experiments were formed to develop a theory, is what this is. So it's an accumulation of all the experiments to kind of put a general summary of what they believe is taking place. And so that's called a theory. So, all right. Okay, let's take a break.
We were in a meeting with the state. Kept trying to send us this document that we were talking about. These are who could see. So they tried to send it. So I texted IT. I'm like, is the server down for email? So like, no. So he sent me a text message. I said, yeah, but I'm not getting it from the outside. He's like, well, who are you trying to get a phone from? I'm like, this week. He's like, yeah, they're trying to send macros. We don't allow that. So I'm like, will you send it through? So they did send it through. I'm like, really? I'm just reading this thing. Starting to build these quantum computers that work with computers for finding computers. More powerful and great beautiful things to use to be equipped. Yeah. Yeah, so all the defense, all financial, all the defense programs, and will all be anybody that owns computers be very I mean, how they interrupt. Oh, it was like on. But they have to work with the super common, so they have to make them ready. That might be on the right. All the beans come from. Yeah. So we all, are trying to make so much.
Oh, no, that's right.
You don't want to. Yeah, China's getting big. So it's like we're gonna get fighter jets. I know. And then I do the only thing one time. One big sniper. Why not? Why not keep messing around with it? Yeah, we got a song. It's a lot harder to find. I don't. That's one thing I don't have. I was home too, yeah. I was home. I honestly wonder how much support you know, killed because someone might step up. They don't know. I don't know. He doesn't. It made a great. Yep.
It is amazing, like, whenever I do this particular talk, when I take a break, it's always here. No, yeah, I felt like I was really going slow today. And maybe I am, I mean, with
Okay, we better get started. I took a longer break than I anticipated. Getting older, you know, just sit down, recover. What's that? Okay, something I have to look forward to, huh? It does not get better. Okay. Yeah, I have a feeling. All right, so the kind of new section now we're going is as far as IPM and this was stolen from the medical profession. And as far as the prescription without diagnosis is malpractice. And so therefore, with at least landscape IPM or any kind of IPM, monitoring is essential. That's the focus of what it's all about. And so this next section is actually more designed for more of a commercial type of an operation. Although as a homeowner, for the certified gardeners, you can still monitor your own home landscape if you so desire. You can do this like anybody. And so therefore, to try to make things a little more simplistic beginning, what has been attempted is to kind of have a focus areas, or where initially you kind of make things a little more easier to get started. And so you would focus on the key plants, the key pests, and the key locations. And so it'd be more efficient when you're doing this monitoring and not wasting time unnecessarily. And so as far as New Jersey, some of our key plants are listed right here. I think everybody, probably all these plants, these types, you have many of them probably in your own yard, and they're readily available. They're inexpensive. Almost any your homeowner, rather a garden center, will have them available. Your next door neighbor has them, and so forth. And so you recognize just about every one of these, I would assume. However, they're also a good representation of what we would call problem-prone plants. I mean, they're going to be more susceptible to, say, insects, pests, and diseases, pathogens as well. And so this indicates that you have to focus on these plants because they're going to be more likely to have problems. And so that's a good way to kind of narrow things down to know where to, to focus, right? And so therefore, these are some of the key insect diseases. I italicized the diseases there on the bottom right, kind of shortchanged them. There's a lot more diseases than that. But these are some of the key insects that I have listed here. And oftentimes these key insects or mites will then be feeding on the key plants. So you have the key plants and you have the key pests, and you kind of go hand in hand. And certain times of the year are going to have good possibility of getting the key insects or the key diseases. Some of them are showing. All right. Again, I think at least a few of these insect pests are native to people. We've already talked about spider mites to some degree. Azalea lace bugs are another one, and I know for the certified gardeners, a month ago we kind of went over this a bit. I don't think I showed this slide though, did I? No, I didn't think so. There's kind of a little bit of an overlap between the IPM talk, what this is, and then the key insect mite pests I gave a month ago. So there's going to be some overlap. Most counties, when I give talks to certified gardeners or master gardeners, they don't ask me to give both talks to the same group. So you guys are special. And so therefore, there might be a little more repetition than what, I don't always know what I've talked about in the past. So anyway, and again, we mentioned some of these. We've talked about the euonymus scale, and I don't know if we talked about anything else, maybe bagworms a little bit. And birch leaf miner is no longer the problem it used to be. Again, in the 1980s and 1990s, most of our birches were routinely applied with insecticides, knowing that every spring they were going to get these birch leaf miner insects that causes the birch leaves to defoliate and weakens them and makes them more susceptible to the bronze birch borer, which is up there too, which is a killer. Wood borers are the true assassins of the landscape, and so we weaken the trees with these birch leaf miner. But they're gone. I mean, I don't see birch leaf miners as any like I used to, and they used to be key pest. And so actually, I should remove that from the list of key pests or insects in New Jersey, because the birch leaf miner is no longer anywhere near the key pest insect that it used to be. Why? What happened to it? I believe it's nothing that I've read in the literature that substantiates this, but back in the 90s, I think, or even in the 80s, they were releasing a lot of these parasitoid wasps that were targeting the leaf miners. And they reached such a high population level that the parasitoids were able to really successfully suppress the birch leaf miner to a very high degree. So yeah. Yeah, it is. New Jersey, that's right. I think it was first introduced in Pennsylvania, Bucks County, in 2014 is when they first discovered it. It didn't make its way into New Jersey until, at least it wasn't discovered until 4 years later, in 2018. So it's been with us for the past seasons, 18, 19, 20, 21, 5 seasons. So, yeah. Yeah. I know that's what's recommended. And I was talking to a well-known entomologist a couple of weeks ago at a conference in Pennsylvania. His name is, he's really well known. He has national, if even international reputation. His name is Dr. Michael Raup from University of Maryland. And he was saying he's actually kind of disappointed in the fact that we are telling people to kind of really be fearful of this insect, or not so much because of their nuisance. But the thing is that the actions that we're doing physically are very minimal as far as the impact on our populations. It's more of a feel-good thing. So when they, they've had the, governments are saying stomp it out program. This, and what his concern is, it's creating an intimophobic reaction to the young children who are hearing this. And so that extends on later in life, that they have this favor toward insects. Maybe it's inappropriate because insects, many of them are very valuable to us. And so I have a statistic I'll show you a little bit later on, maybe the last 20 minutes or so, showing you how valuable beneficial insects are. And that, we do have this tendency of Americans to be entomophobic. And I think this reaction we've had with the spotted lanternfly, even though it's a tremendous nuisance, and it can be an economic loss to vineyards, grapes can kill grapevines. With landscapes, it's not going to really kill too many trees, almost none. And it's just a tremendous nuisance because of their numbers and the honeydew that drips down off the tree. And so the actions that we're doing with scraping off the eggs, more than 90% of the eggs, if it's a tall tree, are above 10 feet. So we're maybe removing just 5-10% of them at best. And so the impact we're making is probably pretty insignificant. It's more of a feel-good thing. And so anyway, and I was guilty of doing that too. I was kind of brainwashed because I was talking to this entomologist. We were having lunch together. He said, "Yeah, I'm kind of disappointed in you, Steve. Did you step on these? Why are you bothering doing that?" Well, it was recommended. I thought it was a good idea. Scrape the egg masses. Yeah, you know how percentage of them you're actually doing any impact on? Very, very few. Tiny percentage. So, anyway. All right. So get on that subject. All right. So just remember, of course, when we're dealing with insects, they don't all come out at once. Obviously, there's different species and they have different life cycles and they emerge at different times of the year. Sometimes there's just a single generation. Sometimes there are multiple generations, like aphids and spider mites, and so they kind of peak around that June-July period for many of our insects, and then as we move into the fall months, then obviously the cooler temperatures, they get less and less. Okay, and there are some plants I don't necessarily recommend. Some of these are invasive, so they're not being recommended. But maybe these plants have a little bit less of at least more than a little bit in some cases, of a susceptibility to some of our major insect diseases. And there's certainly some of these plants that have problems. But so when you're walking a landscape and you see these plants, maybe you don't necessarily need to spend a lot of time on them. Maybe glance over them quickly, and they may not have much of a problem going on with them. That's especially true with insects. And so key locations are where the problems are typically going to be found, such as these types of locations. Usually they're sites that are more going to be stressful to the plants, makes them maybe a little bit less conducive to beneficial insects. If it's especially a hot, dry, dusty area, you'll have fewer beneficials and the pests can be more of a problem in those sites. And some of them are just just stressful areas for the plants. Too wet, too dry, too shady. And so it's extremes in different directions. And so just be aware of these types of locations. Maybe spend more time looking for problems there. And this is an example of a hot sunny and dry site. They, again, I may have showed this before. Did I show this before? I did. See, I told you, there's some repetition here. This is not something that I say is not a bad idea because of it was a cul-de-sac that was made, a little miniature cul-de-sac in this driveway, pretty good sized home where they have a big driveway. And so they decided to make this central planting island, put plants, stuck some plants in, and then put stone mulch around it, marble chips and stones, instead of actually composted mulch, which would be the best thing for the plants, or just regular hardwood mulch would be better than nothing. But this is an example where there's going to be problems for these plants. Beneficials don't like the sites like this. It's going to be too hot and dry for many of them. They like more cooler or moist type environments for beneficials. All right? And so this is not a good photograph, you might say, but it's not. But it's a hedge. It's a azalea hedge. Got a little leggy because there's too much shade. But there's going to be, I mentioned before about the azalea lacebug, which is common. The number one insect pest by far on its prey is the azalea lacebug. Feed on the undersides of the plants, and they suck the cells, the plants aesthetically unpleasing appearance to them. But there'll be lots of predators in a site like this where it's going to be cooler and shadier. You have things like lots of spiders and green lacewings and lady beetles and so forth, and parasitoids. They'll gravitate to sites like this because they thrive. So there'd be less of a chance for having lace bugs on a site like this. And so, if you're going to kind of look around and use tools, these are the ones that when I was working, this is what I would always do. And I still do when I do monitoring in nurseries, for example. I try to carry most of these with me. The one that's the two most important ones you might want to say is the hand lens right there. And I have multiple hand lenses. I use different magnifications, 5x, 10x, 15x, 20x. Then I have what's called the white beading tray, which I know I talked about, where you wrap the branch you suspect has maybe some insects on it to see what's there. Kind of speeds things up. You don't have to always use your hand lens to look. Just do a quick beading tray test and see what falls out onto the 9x11 piece of paper. I use it on a kind of clipboard area, so, and see what comes out. Usually, most commonly done with spider mites, but you can use it with other insects as well. And everyone knows what this is here. Soil sampler or soil marker gives you a profile deeper in the soil, maybe a good foot or so, and gives you maybe soil type, moisture levels. For the turf managers, they're looking for thatch thickness. Anything really ½ inch is good. When you start getting much more than a 3/4 of an inch of thatch, like we talked about last time, that's considered I don't know if we had a chance to talk about thatch last time. I'm not sure. But that's considered to be undesirable, creates environments for insects, and creates like a hydrophobic layer. The roots don't get proper irrigation. Oh, it's a Felco's pruners. That's in a, I clipped that on my belt. That's an old photograph. I have a much more recent one. That one's gone through the wars. It's pretty beat up, but yeah. All right, and so the hand lens, I thought I'd wait about this, so I'm going to move along real quick for those who are more commercial group. Hopefully you do use a hand lens. As I always say, never walk the landscape without a hand lens. All right, and this guy's almost doing it right. So you put the hand lens, like I talked about before, right up against the eye socket. Choose your dominant eye. I couldn't use my right eye; I couldn't focus right. But my left eye is my dominant eye, and really works really well. And these things like this, which I know I showed before, got all kinds of signs there. Sorry, everything at the top keeps getting blocked off, but I'll explain what it is. These are mites actively moving around on their webbing. We got some caskins. Remember I talked about white caskins and white eggshells. They're all there at the base of the twig. You got some eggs there as well. And so you see this with a hand lens that with the unaided eye, you wouldn't be able to detect. And so it's really important with eggs in particular. You maybe can see there's many eggs here. There's going to be a major increase in the population in a short period of time. So that information all becomes valuable. And so as far as action thresholds, that's that density when it gets to a certain level where the damage, and this is more aesthetic information now, it's difficult for a lot of greenhouse and nursery to really accept action thresholds. They realize they're not going to get 100% control, but they really want to come close to that. With the landscape, you can be much more tolerant. And as I indicated, in the beginning, it's been even done with surveys. Most homeowners can tolerate 5 to 10% damage to their plants, their landscape plants, without really being noticed by them. I mean, if we look more closely, we can see the damage, but it hasn't reached a level that's unacceptable. So there's been thresholds that have been attempted by this. They've actually put numbers on it, which I don't think many because it's too difficult to work with numbers. But this is a few of them that have been listed here. Probably I'll just mention 2 of them. And again, I don't know if I've talked about this before with the certified gardeners, but spider mites, using that 9x11 piece of the beating tray. If you don't just do one test, of course, you do multiple tests. And in this case, if you consistently in an area do 4 branches that have 20 or more of these mites moving around, these spider mites, and if you don't have any damage yet to the plant that it's feeding on, you might soon experience it. So that would be considered to be kind of a beginning threshold where, it's eventually the plant's going to show maybe some unacceptable damage. So that's one number that's used, 20, and you do it more than once, of course. Another one is bagworms here. I think you're familiar with bagworms. We talked about it again. And this is one where they say that this research was done by an entomologist in Ball State University, which is in Indiana. And he worked with nurseries. So he was his observations with, I think he used columnar arborvitaes, for such a popular plant. So that's why he used it. So he found out that when you have more than one bagworm per linear foot, so if you maybe have a 10-foot arborvitae, you can tolerate 10 of the bagworms, and their damage will not be that much of a concern. However, each year they lay hundreds of eggs. So for the following year, you're going to be far exceeding that with the thresholds and the density. So, but early on, it can tolerate about 1 per foot. So that's another number. At least some of these other numbers can be used. I never really used them too much when I was a landscaper, but we kind of develop over time. We have a feeling, because we see enough of these plants and the damage that happens and the populations of insects and mites, we kind of have an intuitive feeling. It's not scientific. It's an intuitive feeling of what's a mild population, what's a moderate population, and what's a severe higher population. And we just get a kind of a feeling of what those numbers are, which will even it hasn't already. So yeah, once we already have, obviously significant damage on a plant, the thresholds are usually out the window. It's got time to make an intervention. Okay. And so, of course, the plant and time of year are 2 key pieces of information to improve scouting efficiency. And I know you're going to have Richard Buckley come and speak, I think Mary said, in a couple of weeks. And he's going to emphasize things like symptoms and signs. And did I talk about that? I probably did. Do you remember? I did, yeah. All right, maybe you can tell me. Symptoms Or did I give the example of the girdling roots of the Norway? Did I give that example? I didn't. So you didn't hear that. All right, good. So let's say you're observing your Norway maple, not really considered a highly prized tree species. You know, it's got a very shallow root system and very dense shade, hard for a mature tree to have any turf grow under a Norway maple. The shade will be too high of an amount. So you look at the tree, say from the curve from a distance, and you see that some of the branches are starting to die back. So that would be the symptom. The plant is showing, expressing something that's not desirable. It's unnatural. So then if you look more closely at the tree, maybe you'll see, and Norway maples are notorious for this, and it has, especially when they're planted too deep in the landscape, you'll have a girdling root starting to grow around the trunk of the tree. And they start grow together, and roots and the stem of a tree are not compatible. I mean, they can't graft together. So the roots just starts to press in and essentially chokes the tree and causes a disruption of the vascular tissue, because the phloem and the xylem are just right next to the cambrium on each side, and they're just right inside the bark of a tree. So when you get this root that's starting to press into it, you start having restrictions of the vascular tissue. And if it girdles it completely, the plant's going to die because it can't get water from the roots, and the roots can't get food from the leaves. And so that's all disrupted, and the plant won't survive. And so what's going on, if you look and you see that girdling root, it's causing, maybe take a few years for the tree to eventually be killed. But as you see the branch die back, that would be the symptom or the sign. So that's how those two terms work. People often exchange improperly those two terms. They interchange them, but there's a distinctive difference between a symptom versus a sign. So when you're going through the diagnostic process, don't make sure you're using the right symptom and sign for what's going on. Right? And so symptoms versus signs, and there's examples of symptoms. Things like leaf mining and stippling is a real important symptom. Things like lace bugs that feed on the cells and causes chlorosis or discoloration of the azaleas or rhododendrons, different species of lace bugs, andromedas. We have shade trees with lace bugs as well, or spider mites, different species of spider mites, and they feed in the cells as well. They cause chlorosis, much finer type of chlorosis, because of course the spider mites have mouth parts that are tiny compared to the mouth part of a lace bug, which is multiple times bigger. And chlorosis is what they cause to the foliage, kind of a yellowing or discoloration, flagging and stunting and skeletonization. When Japanese beetles were really common, there's another insect that's not what it used to be. In the 1980s, that was a major key pest in our landscapes, especially residential landscapes, new residential landscapes. They'd come in and just tear up certain types of trees and roses. They loved roses, they still do, but they're not nearly the population they used to be. They have been apparently outcompeted by the oriental beetle. Just like the Japanese beetle, it's a type of scarab beetle that feeds on the turf of the roots. But the oriental beetle does as well, and they've outcompeted the Japanese beetle, at least in most parts of New Jersey, where it used to be when we would say white grubs, we were talking Japanese beetles. I mean, it was just expected. Today, that's not true. Many times Japanese beetles like number 3 or number 4 down the list, and they're just not nearly what they used to be. So these things, they change, they cycle, they come and they go. That's probably the same thing was going to happen with the spotted lanternfly. Some areas have already reported that they've reached a peak level, then they start dropping. Those that have seen them for a number of years. So that will probably, the spotted lanternfly will disappear, but they may have, you know, fluctuations in their numbers in certain areas. Okay. All right, so those are symptoms that read the signs, and that's the causal agents and their byproducts. It's the insects themselves or the diseases themselves. And we've talked about insect and mites, and those are active signs. Caskins and frass and honeydew are byproducts that those insects or mites produce. Anything with webbing and eggshells and eggs, those are all signs. It's so just, yes. Yeah. Yeah. Well, you know, when you see the signs, you know, that's what's the cause. And so that tells you what it is. And if you want to intervene and you know, what could be done to get things back under control. I mean, you could immediately go to an insecticide, but you know, maybe it's something trying to produce a landscape, for example. This takes time to do this, but to have a landscape that has maybe a little bit more shade in it, a more mature landscape, which again will take time, and having a large, complex amount of plantings with many different species, and then a lot of flowers, because beneficial, try to promote beneficials. I give a talk of entitled in inviting insects into your yard. I mean, for me to have said that to one of my customers with the company I worked for 40 years ago, yeah, Mrs. Smith, we're going to invite some insects into your yard. We're going to be doing some design changes that you requested. And that mentality wasn't, what are you going to do? What? Not realizing that we're going to be introducing many or promoting so that they stay in a certain environment. These are beneficial insects. So, and then because you have so many different plants for the pests to feed on, they're going to be there too, but the beneficials will have, again, that dynamic equilibrium if you establish it, and this will take time, but that would be a long-term solution. So otherwise, if you have something that's just one immediate results, you know what the problem is, and you know what kind of insecticide to use. That solves it as well. That's a kind of a simplistic approach, but it's not a long-term approach, because you may have to continually intervene year after year until you solve the site conditions. That's, or maybe the type of plant that you have there. Just change it completely. Yeah. Of course, yeah. Yeah. You know, there's quite a difference when we talk about the aesthetics with landscape plantings, and then things like I mentioned already about nurseries and greenhouses. They have a pretty low threshold that's tolerable. And the same thing with edible plants too. I mean, we tolerate a very low amount of damage on those plants. So we're kind of talking a different scenario there. I'm promoting landscape IPM here. So we're talking aesthetics and not more economic impact. It's indirectly economic, but it's not the same. So that's why there's different categories. You know, you have fruit IPM, vegetable IPM, because it's all different. And so, but my area of specialty has always been landscape IPM. So that's kind of answers that question that what you asked about. So, yeah, we have people at Rutgers who specialize in vegetables, and they give the same talk, but they focus on vegetable IPM. And there's difference. There's sometimes significant dealing with different plants, different species, different insects, different diseases. Different. Right. So, and then we got this diseases. I kind of short-change diseases and pathogens. Most of them are going to be fungi. So we have bacteria, we have viruses, We have nematodes, that are more of a problem with turf grass primarily. Occasionally, I do have foliar nematodes on some plants in nurseries. Buddleia, especially, come across Buddleia, the butterfly bush. So, right, and fruiting bodies would be an active sign from a fungus. So, mycelia also, the fungal strands, the hyphae from a fungal disease. So you look for all these, so you know what you're dealing with, and you can identify insects and pathogens based on the signs that are there. Okay, as far as symptoms here, we've got our classic example of an arborvitae again, and we have the bagworm. Again, I showed this, but this is showing you a symptom of a bagworm infestation, and usually you see the symptoms at the top of the tree first. There's a reason for that. I'll go through this quick because I think the gardeners have already heard about this. Is that the females, they mature, one generation here, and they feed off of these caterpillars. They can feed on many different hosts, but their favorite is, one of their favorites are arborvitaes. Must be candy to them. They can decimate an arborvitae in 1 or 2 seasons, and defoliate some of them within 3 years, 4 years. The tree's dead from the caterpillar feedings. But what happens is that the female bagworm, the caterpillar stage, before she pupates and becomes an adult, she'll climb to the tops of the trees, and then that's where she'll pupate. And then the male comes, the male can fly to her, she releases pheromones, and then she is mated, and she will lay eggs within the sac of the bagworm. You're familiar with those. And they're at the tops of the trees, though, and the eggs are up there. And why would they do that? Well, it's because when the eggs hatch, a good percentage of them, 50%, 75%, they'll take this leap of faith. Tiny little caterpillars will weave a little bit of silk out of their mouth, and they'll catch the wind, and they just blow the wind. And so the ones that remain stay there. This is how they spread their population. This balloon, it's called a ballooning stage. Other caterpillars do the same thing. Spongy moth has a ballooning stage. But so the ones that remain are the ones they're already at the tops of the trees. So that's where they feed first. So that's why you see the damage there. So those are symptoms, and there's the sign. Okay, and, right. That's the big caterpillar. That would be probably sometime in September, right before pupation occurs. Right. And there's spruce spider mite symptoms there. The chlorotic stippling. These mites are feeding in the spring and the fall because they're cool season mites. So the new growth came out. So they fed in the spring or the previous fall, and they caused this chlorosis or off color. And then by the time the new growth started, which is most of the elongation, probably in May, the spruce spider mites would not have the opportunity to do much feeding on the new growth. And so in the summer, the new growth looks good. It's just the older inner growth that has the damage to it. And then in the fall, then they will become active again, the spruce spider mites, and they'll then feed on the new growth. So that's how that works. So these would be the symptoms, and then these are the signs. Okay. So. Yeah. Yeah, normally they'll feed on, they prefer to feed, most of the feeding will be done on the outer newer growth, but unless they haven't had time to do it, because they feed when in the fall on the new growth that occurred during the summer, and then they'll do the same again in the fall, and then this new spring growth comes out, but then they become inactive because it gets too warm for them later in the spring, and so that new growth hasn't been fed upon yet. But to remove it, then you're removing 2 years worth of growth. That doesn't really work out too well. So. Yeah. Spruce spider mites could cause a lot of webbing, as well as the two-spotted spider mite, which is the warm season mite. So yeah. All right, so the second thing, I'll tell you what, I have to, my time is running out, so I have less than about a half hour, I think. So I'm going to run and go to the beneficial insects section. So I'm going to skip through about 24 slides. This will be a flash show. Growing degree days, plant phenological indicators. I want to have time. So this is it. Not that many, actually, not 24, but 15. So IPM, as we've talked about, uses natural control agents. We use something that works advantage and enhance it and avoid destroying it, like we've shown with those graphs and the dynamic equilibrium that's become established, and then we disrupt that with our chemicals that are unnecessarily done. So IPM does use natural control agents, and in an ideal world, which is not reality, it would always look like this, right? You never have to treat, never a problem, because it's always going to be below the action threshold. Well, that's not reality. That's more of reality. Occasionally, the insect pests or the mite or what have you will have a competitive advantage, maybe at least for a short period of time. Often it's when the become elevated and the pests can really go build up their numbers fast. And because of the time lag associated, the beneficials, they try to keep up, but they can't quite keep up for a certain period of time when those elevated temperatures are present. And so you do get to the point where we'll eventually catch up, as shown here, but there's going to be a period of time where damage does occur, and maybe it'll be unacceptable damage because you've exceeded the action threshold. And so there will be times when the beneficials don't quite do the job for you. Be very helpful at other times when they don't have the pests don't have that competitive advantage. So what the biocontrol entails, like what he mentioned, is the fact that we have our predators. Predators are a bit larger than their prey. Most predators, many of them have multiple hosts. They feed on many different pests. And sometimes they feed on things we don't necessarily want them to, that are maybe other beneficial insects. And so then we have these parasitoids, which are, these wasps, and some of them are fly species, and they are the parasite host. Then we have the pathogen. Won't have time to get the pathogens. I did spend a few minutes talking about the entomophic fungus that did a great job of suppressing the spongy moth or the gypsy moth populations. And so pathogens are a valuable thing as well. All right, so predators they're typically bigger than their prey, and they kill them rapidly. All right, and some of our common backyard beneficials, you go in your backyard if you have a sufficient number of plants, and you can look, you'll probably see them on occasion. These beneficial predators. We all know this one, I think, right? Yep, that's a Otheca, which is the praying mantid egg case. You may have anywhere from, I think, what numbers I've seen, 100 to 150 of them in each one of these cases. And they overwinter in this stage, then they hatch out in the spring, and there they are, all hatching out. There's over 100 of them right there, and probably many more that haven't yet hatched, maybe a few dozen more. And so the question is, are they, and I may have already asked this question, are they valuable beneficials in the landscape? There's the catcher. Yeah, they are excellent predators. They are. They're not valuable in our landscapes. They're overrated. They are, because a lot of the pests we have in our landscapes, spider mites, scales, lace bugs, aphids, they're not all that interested in those, or they won't feed on them at all. And so they want something a little more substantial. And praying mantids will go after things bigger than they are too. And they themselves, if you've seen it, if it's the Chinese mantid, which is the one we got from Asia, they can get over 5 inches in size later in the fall. You see them, It's kind of startling because they're just a big insect and they can fly really well. They can take off almost like a bird, but they're kind of overrated in the landscape. They're feeding on things often that we don't want them to. They'll feed on butterflies. They'll feed on things like beneficial insects, lady beetles, lace wings, the green lace wings, which are beneficials, not the lace bugs, but the lace wings, which I'll talk about, which are beneficial predators. And so they feed on other things that we don't necessarily want them to. So they're opportunists. They just feed on anything they grab. And so therefore, and they don't build up to large numbers. They're very territorial, and they can be cannibalistic. They'll fight each other off, and so they don't allow large numbers to build up as a density in a certain area of the landscape. So you often won't see a lot of them. In your landscape, we'll probably see maybe a few here and there, perhaps, but not to a large number, not enough for them to be of much use or value as a valuable predator. So there it is. And it's not, no, it's not. It's not a valuable landscape predator. So that's, they're an I wouldn't necessarily kill them. I definitely wouldn't kill them if you see them. But yeah, they're really a fun bug to work with. Oh yeah. Why don't we see as many of the Othukas like we used to? I still see them a lot, but you know where I see them most often? Christmas tree farms. A lot of Christmas tree farms. In fact, some Christmas tree farm owners, the growers, I haven't had this happen to me a few times. What can I spray in the fall against praying mantids to kill them? And I hate to see that happen because, but they become a real nuisance once they, they mate and then they lay eggs and attach it to the twigs of the Christmas trees. And then they have a choose and cut program. Homeowner brings it back and the warmer temperatures, and it's Christmas Day and they're all hatch out. And it becomes a real nuisance. And then they call the Christmas tree operation and says, you got a problem here. I have a problem and it's a problem too. And they complain. So they try to catch them before they take them off the property, but they miss many of them because sometimes they might be a little deeper in the tree. They don't. Right?
Is there an actual threshold for
praying mantids?
field?
I don't know of any. They don't want any of them because it only takes one customer who's unhappy, and they don't want to see that because maybe they won't get that customer back the following, December or whenever they purchase the trees. So yeah, Christmas tree. It's really a family, almost always a family-owned operation, and they have their loyal clientele that comes back every year. And many times they cater to the families and they provide entertainment. And they want the same family group to come back each and every year. Yeah. Oh yeah, yeah, yeah. No, I'm not aware of it. Yeah.
Because they're beneficial to a point.
Yeah.
You don't want to get rid of them all, but you want to-
Yeah.
I mean,
Yeah.
there's a problem with it, that's what I prefer to trade.
That many you found? Wow. Wow. Yeah, I see them a lot in the fall. I got my best photographs in the fall on Christmas trees. Spiders are great predators, of course. They're probably underrated, creepy crawly spiders, but they are outstanding predators. Many different species of spiders. This happens to be a wolf spider. It's pretty good size, and so I can't imagine again, going up to Mrs. Smith. Yeah, we're going to release these wolf spiders on your landscape. Nah, I don't think that would go over too well, but they occur naturally. And then we have our lake beetles here. Everyone's familiar with that. And these are the eggs that they lay. These are usually about a dozen or so, like little yellow bowling pins. That are... Big one, it's probably a predator against aphids, although it can feed on other things like lace bugs and a few other pests that'll feed on them. Some of them, lady beetles, like I said, they're oftentimes different species that can be quite host specific and go after certain hosts of pests that they like. So this is one that will often on aphids. And we don't necessarily recognize this one, but it's usually oftentimes, and those, the adults are good predators too, but oftentimes with predators, it's the immature or the larva or the nymphal stage that are even better predators than the adults are. So that's the pupation stage of the lady beetle, and so this one's changing over from the larva into the adult stage. And there's an adult, this one is a tulip tree scale, and it's trying to, it's a soft scale as opposed to an armored scale. So you can't really remove the cover. So what this lady beetle is attempting to do is to, it has adhesive that it applies itself to the branch. So what the lady beetle is trying to do is to lift up that adhesive and get underneath the scale, because they don't want to kind of go into that gummy exoskeleton that it has, and then kind of get underneath where the meat of the insect is on the underside. So that's what this insect is trying to do, this lady beetle. Now we have all stages of the lady beetles here, not a great photograph, but you have the yellow egg, you hatch out, you've got the white eggshells that are there, always going to be white, no matter what color of egg it is, you're going to have white eggshells. You have 3 immature stages, really quite small, doesn't have much coloration to it, this first instar or developmental stage. And they have, I believe it's 4 instars, lady beetles, could be 5. And then they eventually get larger and larger each time they molt to another instar stage, or in this case, the new larval stages. And by the way, with insects, I know I mentioned this, I'm sure I did, just a good reminder, with those insects that have a complete metamorphosis, meaning they go through all 4 life stages as shown here. Their immature stages are called larvae, and then if you have an incomplete or partial metamorphosis, means that it doesn't go through a pupation stage. Those immatures are called nymphs. So it's nymphs or larvae, depending upon if it's complete or partial metamorphosis. Right? So with the spotted lanternfly, are those larvae or are those nymphs that we see? They're nymphs, yeah. They don't have a pupation stage, a complete metamorphosis. Yeah. So, and then of course the pupation stage here, and then you have the adults, right, making more of their own kind again. And so here we have a lady beetle larva shown. It's called the Schlacherus species. And this is an insect mimicry because this is a lady beetle larva, and it's trying to feed on these tulip tree scales, which produce honeydew. Armored scales do not produce honeydew. They feed in cells, but the soft scales and all other families of scales, they feed in the phloem or the sap. So they release honeydew. And so ants, they love that honeydew. That's a free food source. And so they will fight off predators who are trying to kill their food source, like the sheep herder will protect his flock against the wolves. The ants do the same thing against the predators who are trying to eat their food source and the honeydew that they're producing, that free energy source. So they'll fight them off and protect them. And so evolutionary adaptation, this insect mimicry has occurred, where some species of lady beetles don't want to be detected by the ants. They don't want to have to be dealing with fighting off these ants as they try to prey on the honeydew producers. And so they mimic the appearance of a mealybug, which is another type of scale that also produces honeydew. And so therefore, the ants will not attack this look-alike mealybug, even though they should. And so therefore, they get away with it. And so the predators can consume the scales without the ant coming in and fighting them off. All right, and there's a close-up of the Shalacris beetle. Okay. And here's a lacewing adult. That's the lacewing predator. And this is the psychopath of the insect war. That's the immature stage, the larva. And so they're feeding, they have mouth parts. I don't know if I have a close up. There you go. The mouth parts are sickle shaped, and it's a hollow, very sharp, as you can tell, and they impale their mandibles inside of a soft body like an aphid or a lacebug, and some scales and so forth. And then they release some enzymes that allows the body fluids of their prey to become somewhat liquefied. It's easier for them then to suck the fluids out of their host. So these lacewings are very good at doing that. All right, and they lay their eggs on a stalk. These are green lacewings. They do that because the larvae of the lacewings, the ones that hatch out first, they're psychopaths. They'll start eating their unhatched brothers and sisters. So the female is a good mother. She wants to protect her young. She lays them on a stalk, the eggs. So once the first ones will hatch out, they can't easily go back up and try to feed on the eggs of their unhatched brothers and sisters. And so it kind of allows them to survive, to hatch. And you can see this was upside down. I should have changed it, rotated 180 degrees. This is the midrib of a leaf. So you turn that over, the aphids are underneath the leaf eating, and then the stalks of the lacewing eggs are hanging down. Although they can hang up as well. The silk threads are rigid enough where gravity doesn't pull them down. They can still stand up. So you can see them sticking up too, or down. You'll see that with the lacewing eggs. That we see a lot, maybe you don't realize what it is. That kind of looks like a little miniature yellow jacket. These are flower flies, excellent pollinators. Also, they're called hover flies because they hover in space, like a little miniature hummingbee. Or what's another name? Syrphid fly is the genus, a scientific name for the flower fly or hover fly. And there's the active predator. So the adult is not a predator at all. It's a pretty decent pollinator because they fly around and they look for flowers and get proper amounts of nectar and pollen. And so they have to do what's called maturation feeding on flowers first. So that's why when you try to have beneficial insects in your yard, you need to have a lot of flowers which contain pollen and nectar for them, because they won't stay in a yard unless they have that food source for themselves. And so then they lay eggs and they release this maggot shown here. Talk about an underappreciated predator. This is a Diptera, which is a fly, the order of flies, and it's a maggot. And it's blind. It's feeding in this case through a field of alder woolly aphids, just meandering around. I guess tactile sensation, it can feel an aphid or something. And so they have a hook-like mouth part. They'll hook it and they'll lift it up and release some enzymes and then suck everything out. And they can do this once every minute or two for quite a few minutes, one after the other. So if you have a lot of aphids, you can find these things. You just have to know what to look for. You'll see these little maggots moving around. So underappreciated to be sure. All right, so I've kind of already gone over this. This is that beating tray, for example, shown here. And you can do a beating tray test by streaking the mites across and they get a blood smear. And so that's a predaceous mite. We have other predators that we don't appreciate very much, like the yellow jacket. Yellow jacket are very good caterpillar feeders. This is a native insect, a native predator, and they'll go after many of our native caterpillars. And they do a dietary change. In their earlier spring and the early summer period, they are they're carnivores. they like protein. But then as you go later into the summer, when you start getting into the early fall weeks, they have a dietary change where they crave carbohydrates. So that's when they become a real nuisance. That's your picnics, Labor Day picnics, the sodas, the potato salads. They like the carbohydrates. So they make a dietary change. Then they become the nuisance that they are. And I tell you, yellow jackets are not something you play around with. These guys can be pretty wicked. And they can sting repeatedly. It's not like a honeybee, one sting and they're done. These guys can continually do it. So yeah, you don't play around with yellow jackets or with a lot of different wasp species. They can be pretty big, pretty serious. My guess is that just about time. My guess is that they're opportunists. Yeah, like a lot of our friends, they don't care what we want them to go after, and so they just go after what they're capable of for their own sustenance. So there's an example here, almost in focus, not quite, where I took this the eastern tent caterpillar. It has that webbing and the forks of trees like crab apples and wild cherries. You'll see them in the spring, the earlier insect pests we have in our spring. And I noticed this one, it was really low to the ground, so I was able to grab it, pulled it back, because what I wanted to make is I noticed these holes. And I knew that was from like yellow jackets that will come in, they'll open up webbing and try to catch one of the eastern tan caterpillars right near the surface. And as I did that, a yellow jacket zooms in and does the quick moving of the webbing around, grabbed one of the caterpillars right there near the surface, chomped it down, drew some blood, and then took off. And you know that probably a number of them were doing this, and they were slowly reducing the populations, not ever to zero, but to a significant level sometimes, if there's enough yellow jackets, eastern tent caterpillar, which is a native caterpillar. And so this is a beneficial in that case, but then it becomes the problem that we know later in the summer when they become a problem with our sodas and so forth. Okay. And so maybe I'll finish up with this one. I was talking to somebody at break about dragonflies. What am I, if I had to say, what is your favorite insect? It's probably dragonflies. I see them all the time in nurseries, and they zigging around, moving around. They can only capture prey as they're flying. So they have to be, in wing. They won't ambush a host or a prey. They can't sneak up on them and walk in and grab it. They have to be flying when they do so. And they can really turn on a dime and really pretty agile, very pretty rapid flyers. And I took this photograph, and I was telling the person during break that this particular dragonfly, I tried to take pictures of them. I was persistent because every time I got close, of course, they become wary and they see your motion. They just move around. They easily kind of evade me. And so eventually I did this a few times, and I guess this particular insect says, I have nothing to fear from this guy. He's just so slow. And so I was allowed to get really pretty close, like this close, and took the photograph, and he finally took off. But and as you can say, he's kind of laughing at me here. So he's very photogenic. Yeah. Yes. No, I'm not aware of them, and they don't have a stinger. They have chewing mouth parts. So you'd be questioning, what do they bite? I'm not aware of them ever having any interest in people at all. If anything, all they do is evade them. And but they are really excellent predators. And then you have the larval stage that are known to be predators of the mosquitoes. Yeah, yeah. So yeah. I take a lot of photographs and some of them are pretty mediocre and others I get lucky and like this one. So. All right, so I think my time is up, right, Mary?
Yeah.
All right, so thanks for listening. I take care.
We can send me that week.
Yep.
Thank you.